Let's go ahead and see where the graph passes through. So we have an x-intercept at -8, 0, at -4, 0, at 0, 0. That's an interesting one here, and at 6, 0. So when we enter the polynomial, we could enter f of x equals to, this one we said was -8, so we will say x plus 8. And it passes through the point -4. So we will say times x plus 4. And then the 0 here will just be times x. And then times x minus 6. Now, you can write this polynomial in any order. Usually we will write the x first. So I'm going to change this around and I'm going to put the x in the front. Okay, let's go ahead to slide 24. In this case, we have a pass at the point -5, 0, a bend at -1, 0, and then a bounce at 6, 0. So let's go ahead and write that equation, and we may have to change the a value. So let's take a look how we would do that. So f of x is equal to some a value. We have a pass at x plus 5, and then we have a bend at x plus 1. We're going to raise that to the cube. And then we have a bounce at x minus 6. So if we take a look at that, let me remove the a value here so we could see the graph. All right, so far the graph obviously is not matching, so we need to change the a value. Looking at the a value, we are going to see where the graph, and I forgot to put a bounce here, so at x minus 6, I'm going to raise it to the second power. Oops. Okay. So we could see that it's almost overlapping, but we need to fix the a value or find the a value. So I want to know what value I should multiply here so that it will match the graph. So let's take a look if we could choose a point on this graph, and it looks like on the blue graph is what we want to match. There is a point. If I look at this, there is a point 0, 90 on this graph. Now, where it is right now, it's not showing, but if I enlarge it right here, this point is 0, 90 on the blue graph. So let's go ahead and plug in the point 0, 90 to our equation. Remember, we could choose any point we would like. So choosing the point that passes through the blue graph at 0, 90, I'm going to enter it into this equation. So recall this is x and this is y, so we are finding the a value again. So 90 is equal to a times 0 plus 5 times 0 plus 1 cubed times 0 minus 6 squared. And if I simplify that, I get 5 times 1 cubed times -6 squared. And simplifying this again, we will get 1 cubed is just 1, so it will just be 5 times 36. And if we multiply that out, that works out to be 180. Dividing by 180 on both sides, we get that a is equal to 90 over 180, which equals to 1 over 2, or if you prefer, 0.5. So let's see if we plug in 0.5 if we're on our a value, if that works. So going back to the graph, I'm going to plug in 0.5, and we have matched our graph. Here it says to write the polynomial equation. So we have a 1, 0, it passes through 5, 0, and a 10, 0, and a 20, 0. So these are all degree 1s because they are just passing through. So I should have x minus 1 times x minus 5 times x minus 10 times x minus 20. And what does it look like? This is 1 that passes. That is a 5. That is a 10. And that is a 20. So it looks like we need to find the a value again. So what do you think? Let's see. This value right here is 0, 40. So doing the same procedure again, we're going to plug in the point 0, 40 into this equation where we have an a value right here. And we're going to take a look to see if that matches. So 1, we have that. 5, we have that. 10, we have that. And 20. Okay, so let's write that equation and find our a value. So I'm going to rewrite that equation. And in a moment, we are going to find our a value, and we're going to select a point on the graph, which is 0, 40. So let's see what our a value is in this case. Okay, so 40 equals to a, and I have -1 times -5 because everything here is 0, and -20. And multiplying this out, I get -1 times -5 is 5. And -10 times -20 is 200. So it's 40 equals to 5 times 200 is 1,000. Divide by 1,000 on both sides. And we get that a is equal to 4/100. Okay, and 4/100 is the same as 1/25. So let's see if that works out. So I'm going to change this to 1 divided by 25. And it does match. So we needed to find the a value here as well.